Hey there, and welcome. Ready to dive into something super interesting? Today, we're tackling Unit 1, Lesson 4, all about chemical bonds. We're going to find out about this secret glue that holds literally everything together. You know, from the salt you put on your fries to the air we're breathing right now. So, let's get into it.
Seriously, have you ever just stopped and looked at anything? Like a glass of water, or even your own hand, and thought, what is holding all this together? Like, why doesn't it all just fall apart into a pile of dust? Well, the secret is all about how these teeny tiny particles called atoms stick to each other, and that's exactly what we're going to look at today.
Okay, so to get how these connections work, we have to think about what atoms want. And you know what? It's pretty simple. Their one big goal is just to be stable. And you could even say happy, kind of like people, right? Atoms just really don't like feeling incomplete. They're always trying to get this full, balanced outer layer.
And here they are. These are like the superstars of the atom world, the noble gases. If you check out their outer shells, you'll see they're totally full of electrons. They've got it all figured out. This makes them super stable and, well, they don't really need to react with anything. They're kind of the cool kids on the block that all the other atoms are trying to be like. So yeah, that's the goal for every other atom. Get a full outer shell, just like these guys.
So the big question is, how do these other atoms get to be like the noble gases? Well, they do it by forming a chemical bond. And a chemical bond, or in Arabic, a rabita الكيميائية, is really just this force of attraction, this pull that holds atoms together. It's that glue we mentioned at the start. It's how they finally get stable. Now, atoms have a couple of options to get this stability. There are two main paths they can take. Let's check out the first one, ionic bonds. A really easy way to remember this one is to think of it as the give and take method. It's exactly what it sounds like. One atom gives an electron, and another one takes it.
Okay, let's look at a real example here. See this sodium atom? It's a metal. And if you look closely at its outer shell, it's only got one lonely little electron hanging out there. Now, for sodium to get stable, it's way easier to just give away, or to lose, which is yafkat, that one electron. And think about it. If it loses a negative electron, what's left? The atom becomes positively charged.
And once it's positively charged, it gets a cool new name. We call it a positive ion, or a cation. So just remember that. A cation is what you get when a metal atom loses one or more of its electrons, its electrones in Arabic, and ends up with a positive charge. That's it!
But wait, where did that electron go? It can't just vanish, right? Nope. It gets snapped up by another atom, like this chlorine atom over here. Now, chlorine is a nonmetal, and if you look at its outer shell, it's so close to being full. It just needs one more electron. So it gains, or yaktesib, that electron from sodium. And when it gets that extra negative electron, the whole chlorine atom becomes negatively charged.
And you guessed it, this newly negative atom also gets a special name. It's called a negative ion, or an anion. So an anion is just a nonmetal atom that grabbed one or more extra electrons and now has a negative charge. See? Simple.
Okay, let's recap how this whole thing happens. It's a three-step dance. Step 1, a metal atom, our sodium, loses an electron. Step 2, a nonmetal atom, our chlorine, snags that electron. So now we've got a positive ion and a negative ion. And what do opposites do? Step 3, they attract. Bam! They stick together, just like magnets. That super strong pull between them, that's the ionic bond.
And get this, you see this happen all the time in real life. When that positive sodium ion and that negative chlorine ion get pulled together, they form something called sodium chloride, or NaC. But you probably call it table salt. Yep, the salt you put on your food. That powerful ionic bond is happening inside your salt shaker. How cool is that?
All right, so that was the whole give and take thing. But what if both atoms want to keep their electrons? What if neither of them wants to give any away? Well, that leads us to the second path, the covalent bond. And for this one, the motto is sharing is caring.
So a covalent bond, in Arabic that's rabita tasahumiyya, this happens when you have two nonmetal atoms and they both need more electrons to feel stable. So instead of one grabbing from the other, they make a deal. They decide to share, or eshtarek, they share their electrons so they can both pretend they have a nice, full outer shell. It's a win-win.
Now this sharing can happen in a few different ways. We've got the most basic one first, the single covalent bond. This is super simple. Two atoms share just one pair of electrons. Look at the hydrogen molecule, H2. Each hydrogen atom has one electron,
so they just share them with each other. And just like that, they both feel stable and happy. Easy.
Okay, what's next? You got it, the double covalent bond, and I bet you can guess what that is. Right, it's when two atoms share two pairs of electrons. A perfect example is the oxygen molecule, O2. This is literally the oxygen we are breathing right now. Those two oxygen atoms are stuck together because they're sharing two pairs of electrons, and this makes for a much stronger bond than just a single one.
And last but not least, we have the big one, the strongest of them all, the triple covalent bond. As you can probably guess, this is when two atoms share three whole pairs of electrons. The nitrogen molecule, N2, is the classic example here. You know, most of the air we're in right now is actually nitrogen gas, and it's all these tiny molecules held together by this incredibly strong triple bond.
Okay, you have been doing an awesome job listening. So, how about we see what's stuck? It's time for a quick check. Don't stress. This is just a fun way to practice what we just went over. Ready? Let's check your understanding.
All right, take a look at the screen. We've got a question here. You can see three different elements. Let's just call them W, X, and Y. And those little dots around them, those are their outer electrons. So the big question is, what's the formula going to be if you combine element W with element Y? So have a look at the choices. Is it A, B, C, or D? Feel free to pause and really look at W and Y. Count their little electron dots. Think about it. Which one is the metal that's going to give electrons, and which one is the non-metal that's going to take them? What kind of charges will they have?
Okay, you got your answer? The correct one is C, WI. If you got that, fantastic job. Let me break down why that's right. So W has two electrons on the outside. It's a metal, so it wants to lose those two electrons. That means it becomes an ion with the charge of +2. Now look at Y. It has 6 outer electrons. To get to a full shell of 8, it needs to gain 2 electrons. That makes it an ion with the charge of -2. So you have a +2 and a -2, they balance each other out perfectly. You just need one W and one Y, so WI. Seriously, great work on that question. Phew, we've gone through a lot of information today, but you're keeping up so well. So before we finish, let's do a super quick summary just to lock in the big ideas.
Okay, so remember, we talked about two main types of chemical bonds. First, there was the ionic bond. The key things to remember there are it's a metal plus a nonmetal, and it's all about giving and taking electrons. That's what makes those charged ions. Then we had the covalent bond. And for that one, remember, it's two nonmetals, and the key word is sharing. They share electrons, and no ions are formed.
So let's boil it all down. What did we learn today? We learned that atoms have one main goal: to be stable, just like those cool noble gases. And they do this in two ways. Either they form ionic bonds by giving and taking electrons, or they form covalent bonds by sharing electrons. And honestly, it's these tiny, tiny bonds that are the reason our world even exists.
And that's a wrap. You did such a great job today. You now totally get the basics of chemical bonds, that secret glue holding everything together. So keep being curious, keep asking questions, because learning is so much fun. Amazing work, and I'll catch you in the next one.